In this tutorial, we'll explore dialogs in wxWidgets. We will build a demo application that allows users to load an image using the system's File Open dialog, change the background color with the standard color picker dialog, and change fonts. Then, we will learn how to build a custom dialog that communicates with the main window through events to update the UI elements. In our example, changing the bitmap brightness. In the end, we will briefly discuss the Progress Dialog and how to use it to run long blocking tasks safely in the main thread. So if this sounds interesting to you, make sure you like and subscribe, and let's begin. Let's start with an empty wxWidgets application with an application class and a main frame. All the code for this tutorial is available on the GitHub repository, so remember to check out the video description. The most basic built-in dialog is a message box. It can be displayed using a single wxMessageBox function call. Here we put that call inside the button click callback. The parameters are easy to understand. The first is the message we want to display, the second is the dialog window title, and the third is the flags parameter, where we can combine various options for our dialog box. In this case, we specify we want the OK button and the information icon. The wxMessageBox function brings the system default dialog for displaying alerts. You can see that the dialog looks quite different on modern macOS than on Linux or Windows. The message box can return a value indicating which button was clicked. Let's add a text view to display the dialog result and update the message box with more buttons: yes, no, and cancel. We choose the correct information to display using the switch statement, ensuring the label reflects the result of the user's action. Testing this application, you can see it works correctly, and the label is updated as expected. Instead of using the wxMessageBox function, we can build the dialog with the wxMessageDialog object and show it with a call to show model. Let's see how this works. Interestingly, we get the same result no matter what button we click. That's because the wxMessageDialog, while similar to wxMessageBox, uses different return constants. We need to change the wxYes to wxIDYes, wxNo to wxIDNo, and so on. Then everything works correctly. A simple way to get text input from the user is to use the getTextFromUser function. We provide the dialog title, text prompt, and default value for the text input field. The function returns the text value, which we display in our main window. Note that if the user cancels the dialog, the function returns an empty string. To distinguish between a user clicking the cancel button and entering an empty string, a different approach is necessary. Instead of calling a method, we built a text entry dialog, providing the parent window as the first parameter, the other arguments being the same as before. Now we can examine the result of showModel call to see which button was clicked and get the input value using the getValue method. We test this solution and confirm it works as expected, correctly detecting the cancel button click. Instead of getting the string through getValue, we can transfer it directly to a variable using Validators. They are responsible for filtering and validating the text input, but also for updating the associated string variables. See my text fields video for more details about validators in wxWidgets. Here, we declare a member string variable to hold the value that the user enters. We then set the validator for the dialog, specifying that we don't want any filtering and wish to transfer the data to and from the username variable. Now, whatever we set the username to, that value will be automatically transferred to the text control when the dialog is initialized. Also, the variable will be updated after the dialog is dismissed, so we can use it in our setLabel call. When we run the app, we get an error. Even though our code compiled without problems, we used the wrong call to set the validator. It should have been setTextValidator, not the general setValidator, which works only for single controls. After correcting the problem, we see that the code works and the data transfers to and from the member variable do happen as expected. The wxWidgets offers more built-in dialogs like this, for example, a reordering dialog or a single choice dialog. I encourage you to check the documentation to see what options are available. Let's switch gears and move on to more advanced system dialogs. In our demo app, we will be able to load an image from a file, change the background color, and set the font, all using the system dialogs. We'll also add a custom dialog for adjusting the image brightness with live updates. We clear the frame constructor, add the necessary member variables for the controls, and build the UI. The null bitmap has a size of 0, and that may cause errors on Linux, so use a 1x1 empty bitmap for the default image. For now, we have just one action button that does nothing. We will add the event handler for that button and add more actions in the moment. Here's our basic UI. Let's add some functionality, but before doing that, let's set the scaling policy for our bitmap to none so that the behavior is consistent across platforms. On Open Image is the callback for the Load Image button, where we'll show the File Chooser dialog. To allow the loading of image files, we need to load image handlers, which we do in the onInit method. After that's done, we proceed to handle the click event. The object we need to create is the wxFileDialog. The parameter list may look intimidating, so let's take a closer look. As usual, we set the parent to our frame object. The following parameter is the dialog prompt, and then the default directory and file to be selected when the dialog shows up, which we leave empty. Then comes the wildcard describing the acceptable file types to the user. The vertical pipe character separates the description from the actual list of file patterns to be recognized by the framework. In this example, we allow PNGs, JPEGs, and bitmaps. The last parameter we set is the flags. We want the dialog for opening files and require that the file exists. If you want the save dialog or change directory dialog, supply a different set of flags, as described in the documentation. After the user selects the file and clicks OK, we load the picture to our image variable. The final thing we need is to refresh the bitmap control. This will be used a few more times in our code, so we create a separate method to update the bitmap with the provided image and lay out the controls to ensure it's displayed correctly. We can see in the demo that our button brings up a standard File Open dialog that you see everywhere on macOS. Similarly, you get the system dialog on Windows and Linux. Let's continue and show the color picker. We need another button and the click callback to display the dialog. First, we ensure that the color picker shows the current background color of the frame. We do this by preparing a color data object that we pass in the Dialogs constructor. If the user clicks OK, we set the background color of our frame to the one selected by the user, remembering to refresh our window. Interestingly, the color picker for macOS does not have any buttons. Closing the dialog is treated by wxWidgets as the confirmation, and the showModel method returns the ID of the OK button. This differs for Windows and Linux, where the dialogs have both OK and Cancel buttons. Also, as was the case with the File Dialog, the color picker we display has a system-specific look, so it feels familiar to the users of the given operating system. The font chooser is another system-specific dialog we will use, this time to let the user change the appearance of the label above the image. As before, we declare a callback, add a button, and bind the click event. We initialize the dialog with the current font size of the label and then call showModel. After setting the font, we call fit to ensure the whole text is visible if the user increases the font size. Here we have our three system-specific dialogs: the File Dialog to open the image, the color picker to change the background color, and the font chooser to select the top label's font. Here's how that looks on Windows and Linux. Finally, let's add our custom dialog for adjusting brightness. We derive from wxDialog, add a constructor with standard parameters, and set up the controls. In the beginning, we'll have a slider and a text showing the adjustment value. Later, we'll add a preview checkbox, allowing for live image updates as the user manipulates the slider. Our slider values range from -100 to 100 with a midpoint of 0. We will convert them to doubles ranging from -1 to +1, as that's the range accepted by wxImageChangeBrightness method. We add our controls to the sizer and then proceed to add buttons. The createButtonSizer method generates the desired dialog buttons and lays them out in a system-specific fashion. Different platforms use different buttons order for dialogs, so it's always a good idea to use this method, ensuring the layout of the buttons looks familiar to the users. Lastly, we need a method to get the user's desired brightness adjustment. The value of 0 means no change. A negative value decreases the brightness, while a positive value increases it. In the main file, we include the custom dialog header and add the event handler and the button to open the brightness dialog, just as we did with the File Dialog and others. Before we display the dialog, we must ensure that the user has loaded an image. If that's the case, we show the dialog, check the return value of the showModel method, and adjust the image brightness accordingly. Note that the changeBrightness method updates the image pixels in place. This will be more important when we add the preview checkbox. As we mentioned before, the adjustment of 0 does not change the image. Any other value updates the brightness. We start from 0 again when we bring the dialog after the update. This is because the dialog operates on brightness adjustment, not some absolute value, so the new brightness level becomes the new starting point. We'll now add the preview checkbox, allowing live brightness updates while the dialog is visible. Before we do that, we need a means of communication between the dialog and the frame. To transfer the brightness adjustment, we'll create a custom event with getters and setters for that value. We also need to communicate the change of the preview checkbox itself, because if the user deactivates it, the main frame needs to revert to the previous brightness. We won't need a custom class for that. The preview checkbox change can be a wx command event. The next steps are simple. Add the checkbox and the event handler triggered by the checkbox change. Here are the helper methods for sending the events. We will use them in both checkbox change and slider change handlers. When the user turns on the preview checkbox, we send the brightness update event, so the client can set the brightness to the current slider value. Also, regardless of whether the checkbox is disabled or enabled, we send the checkbox changed event. Also, when the slider position changes and the preview checkbox is on, we need to send the brightness event, as that's the purpose of adding our checkbox. Finally, we have to handle the events in the main frame. Note that we bind the handlers to the dialog object, not to this, even though we specify that the dialog's parent is the frame. This is by design in wxWidgets. The idea is to prevent the internal events of the dialog from propagating to the window that has shown the dialog box. In our case, we need this communication, so we bind our handlers to the dialog object. In the actual handler of the brightness change event, we have to copy the current image so that the original is unaffected. At this point, the user might cancel, so we need a way to return to the initial state. Since the change brightness operation is destructive and alters the object it works on, we call it on the temporary preview image. The checkbox change event handler is much simpler. We revert to the original image if the user disables the preview functionality. Lastly, we move the bitmap update outside of the if statement. The rationale is that if the user changes the brightness with the preview checkbox enabled and clicks cancel, we need to revert to the original image. There is one small syntax error to fix, and our final version of the demo app is ready. We load an image and change its brightness with the live preview enabled. If we cancel, the image reverts to the previous brightness level. Also, if we disable or enable the checkbox, the image in the main frame reacts correctly. On Windows, you may experience flickering. If that's the case for you, The solution would be to build a custom bitmap control with double buffering. Here is an example of how to do it. You can find this code in the repository mentioned in the video description. Also, check out my custom controls tutorial for more explanation, as this is slightly off topic. The point is, this change fixes our issue. Unfortunately, the custom control is slower than the system bitmap container. To finish the tutorial, let's explore a particularly interesting built-in dialog, the Progress Dialog. We call the constructor and give it a big list of flags to set up the dialog. The first 3 flags tell the dialog to disappear when the work is done, show up as a model, and give the option for the user to cancel the operation. The next set of flags turns on all the timing features, so you can see how long it's taking, how long it should take, and how much time is left. Notice that we don't call showModel anywhere in the code. The first call to update automatically shows the dialog if it's not visible. The update method is interesting. As you may know from my background processing series, you should never run a loop like this in the main thread. Doing so will block the event loop and make the UI unresponsive. That is, unless you call wxYield, which the update method of the Progress Dialog does. It means that during the call to update, the framework can react to events and refresh the UI so nothing is blocked. So with the Progress Dialog, we can and should run a time-consuming operation on the main thread, provided we call update often enough. The update method also accepts the progress value with the maximum specified in the dialogs constructor. When we run the app, we see that the UI does not freeze. Thanks to periodic calls to update, our loop seems to be running in the background. The Progress Dialog can also be cancelled, which breaks out of our long-running task. If we increase the loop count, we see that all the time estimates are automatically updated to reflect that. The system measures the time between updates and interpolates it to calculate the estimated and remaining times. You might find this feature quite useful for your application. Here's how this looks on Windows. We get the same behavior and features, just a slightly different layout. Finally, let's see how to integrate this Progress Dialog with a more useful long-running task. We have an array of random numbers and a slow sorting algorithm. Our task accepts a callback to update the progress and determine if it should quit. We pass the update method in that parameter, and here we have it, a safe execution of a long-running function with visual progress updates, all with just a few lines of code. And that's it for this tutorial. We explored a host of useful built-in dialogs in wxWidgets and learned how to create custom ones that communicate with the parent windows using events. I hope this was helpful, and I will see you in the next one.